You may have heard there are infinite prime numbers, but did you know I can prove it within a minute on this tiny whiteboard? Now let's assume there were finite primes, not an infinite amount. We'll call the biggest prime PZ. Now if we multiplied all of the primes together, we'll call that P primorial, multiplying everyone together up through PZ. And if we go P primorial plus 1, let's name that number Q. Because the number Q, if it's a prime itself, is bigger than any on those lists, so this wasn't a real list in the first place. And if it's not prime, has some prime factorization of smaller primes, like any number. So it must have some primes that make it up. But if we divide it by any prime here, it'll have a remainder of 1, because it's 1 bigger than a number that divides them evenly. So Q must have some prime factors that weren't on the list or be a prime itself, meaning the list is impossible and there are an infinite number of primes.